For our last speaker, we have a very special treat. Joining us from California, basically, for anybody who's ever done, like, read any of the literature on VR, knows anything about VR, has ever worn an Oculus headset and was wondering, does anybody study these things? You know this guy. This is Jeremy Bailenson, and he is the Thomas More Stork Professor of Communications at Stanford University, where he's also the founding director of Stanford University's Virtual Human Interaction Lab. And so today he's going to be talking to us about some of his work and some of the things that's going on in the lab. So Jeremy?
Thank you so much. Thank you for having me, and thank you for having me virtually. I know it would be awesome to be there with all of you face to face, but I appreciate being here with you on Zoom. So what I'm going to talk about today is this incredible endeavor that we've been doing for the past 2 years, which is teaching in VR at large scale, and then studying all the things that happen there from a psychological standpoint, from an educational standpoint. So we're creating something called the Stanford Longitudinal VR Classroom Dataset, and I'm going to talk about some really neat findings and methods and just big ideas that we've been talking about. My Twitter handle is Stanford VR. There's our URL. A lot of our publications are there. This is my last book, and the reason I'm putting this up here is I'm not trying to sell books. The talk I'm giving you today is about really new stuff we're doing, incredibly exciting, and it's all I can talk about, so I really wanted to talk about that today. For those that want a more traditional understanding of the work that we do around the VR space, just send me an email. It's bailenson@gmail, and I'll send you a PDF of the book. This really covers the work that we've been doing for a couple decades in the space. So I'm a PhD in cognitive psychology in 1999. In 1999, I swapped out of cog psych and I went to UC Santa Barbara, where I learned how to build the hardware to make VR work and to program content. And at the same time, I moved away from questions about how the brain works and decision making and reasoning to larger questions about social interaction and education and training. And when I first started doing this work, on the right side of the screen, you can see headsets that cost $40,000 that weighed about 5 pounds. When I first started doing it, there was only a couple hundred in the world. We're now at the point where a headset costs 1/3 the price of a smartphone. And in 2021, we think our best estimate is about 15 million of them are sold. So for those in the audience who've tried VR, and I assume that's a lot of you, you're probably like Popper. This is my grandfather, who is 91 in this photo, who put on the headset and he looked around for a little bit and he said, "This is kind of cool, but what am I supposed to do in here?" Actually, can somebody get, I'm not seeing self-view. Are you showing my slides?
Yeah.
Yep.
Yeah.
Yes.
Okay, thank you. For those that don't hide self-view on every Zoom talk you give, it's a wonderful thing to hide self-view. We can talk about that in Q&A if you'd like. So like Pop, I'm assuming that many of you are like Popper, which is, you see the medium as a really cool thing, but you don't really see the point of it. And a lot of the talks that I give really talk about the applications, whether it's empathy or climate change or education, that really talk about when VR earns its keep. But I'm not going to talk about that today. What I'm going to talk about today is this just utterly mind-blowingly large endeavor that we've undertook. We are in 7/10 of the way through the 4th iteration of this class, where I've been teaching a class called Virtual People since 1999 at UCSB and then 2003 here at Stanford. Virtual People is a class about VR. And I've always talked about this notion of someday we're going to teach in VR as opposed to just talking about VR. And we finally pulled this off. And so the process here, like many professors, when you have to decide what you're going to teach the subsequent year, we have to decide in March 2020 when we're going to teach in 2021. And I volunteered to teach in the summertime. So Stanford at the time was encouraging professors to teach in the summer to kind of spread the amount of people around so that COVID could be spread less easily. And I volunteered to teach in the summer. Of course, nobody wants to do that. It's it's when you go on vacation. The reason I did so is I was hoping that technology would mature enough such that teaching in VR would be a better possibility. And what ensued was a 15-month journey planning and an incredible amount of just thinking and work and innovation. And what we needed to do in those 15 months, we had to figure out hardware. We had to, choose upon a platform. We had to flip the classroom. We had to come up with VR content. We had to think about IRB privacy, and then, of course, all of the theoretical aspects of what we wanted to study data collection wise. And I'm going to go over each of these individually. But I keep using the term we. These people worked many hour days for 15 months nonstop. They were utterly incredible. What I'm going to describe today, we're all hardworking in this room. I have never seen a project that had so many hours put in and hard hours where there was crises and just, it was a really new thing. And these folks just did an utterly wonderful job along the way. So let's talk about hardware. Hardware at this point, if you're going to do something like this, which has put a lot of people in VR for a long time, you have to use something called standalone VR. It can't connect to a personal computer anymore. It's got to run just in the headset. And so the two devices that you could probably use now are the Oculus Quest or the Meta Quest 2 or the Pico Neo 2. We use a combination of them in Stanford. I'm very lucky and happy and appreciative working at Stanford. Stanford has now bought me about 220 of these, and we ship them around the world so that students during COVID could be in VR, and now people have them in their dorm rooms on campus. But if you're going to try something like this at home, hardware takes about 10x more time than you think it will in terms of provisioning, maintaining. One of the huge challenges and time sucks here was that hardware takes a long time to work. Now, on the other hand, hardware is now amazing. The Meta Quest 2 and the Pico Neo 2, you take this thing out of the box and it's working 15 minutes later. Experiences that I could only dream about doing at scale even 2-3 years ago, now we can just show to everyone. So hardware is a big deal, and it's expensive, and but it's really neat to have hardware that works robustly. We're now in the 4th class, and these things are workhorses. They just continue to work after, I could tell stories about what students have done to these headsets, and they largely work well. You've got to choose a platform. So if you're going to be in VR together, things like networking and then inverse kinematics, which means how does the elbow move when you're only tracking a head and a hand? And there's lots of kind of nuts and bolts things that need to get done on the platform. And we spent a lot of time looking at all the different platforms and choosing the one that we want. We chose Engage. Engage is a publicly traded company out of the UK. I've got no affiliation with them formally. I just love them as a product. They've been really good to us, allowing us to changes in the SDK in real time to data collection, which we'll talk about later on. They've been really, it's a platform built for teaching and learning, and I just can't say enough good things about it. Then we had to flip the classroom. So for those in the audience that are familiar with educational technology theory and educational theory, flipping the classroom, we should not be lecturing in classroom. What we should be doing in class is we should, the lecture should be recorded. You do that before you get into class. When we come together during formal lecture time, we should be collaborating, and it should be experiential and constructive in doing stuff. Professors, we don't flip the classroom often, and the reasons are, one, it's hard. We're busy, and innovation takes time. And number two, it's not always readily obvious what you're going to do when you come together in these synchronous moments, right? So what do you do that's active? And so what we decided to do was this. Class is 10 weeks. Every week is a different topic. So one week it would be climate change. How does VR affect climate change? One week it would be ethics. Another week it would be what is avatars and the psychology of avatars. And within that week, on Sunday, they would do reading. So they'd read my books and other chapters. On Monday, we'd come together either on Zoom or now face-to-face, and we'd have intense discussions about the readings, just really going deep, Q&A, calling on people, so that by the time Monday was over, everybody really knew this topic well. Then Wednesday, we'd go on what I call a VR journey. What's a VR journey? Here's one. We would come together on a blank infinite plane, and we would build a scene together. So let's build a winter wonderland. And for an hour and a half, 150 people, I'm gonna put a tree here, and then I'm gonna put a snowman, and ooh, how do we get the physics of snow? And we'd come together and we'd build something. What I like about Engage as a platform, everyone's trying to become the PowerPoint of VR, which is anyone can create content. I'm not saying they're there yet, but they do make it so that non-programmers can create, which is really neat. So that's one example of a journey, and this would be on our education one. Can you build educational content? Here's one on our medical week. We had a week about VR for medical applications, treating strokes and for rehabilitation and others. And our Wednesday journey, we went to Evolve VR, which is a medical group inside of AltSpace VR, which is a platform. And the person in the blue there, that's the Reverend Jeremy Nickel. And the Reverend Jeremy is teaching us paced breathing and meditation. And so those are all my students on the platform. And as he's doing this lesson about meditation, the platforms rise and we go up into outer space and we're looking down at the earth. And as we do meditation, it's a really interesting phenomenon because I would never do meditation in my physical class. That would be mortifying. Like, what professor could do that in a classroom? But VR has this layer of being anonymous in terms of avatars aren't photoreal, and it's just something that on paper doesn't seem like it works, but it was one of the more incredible journeys that we went on. So Wednesday, we'd all go on a journey together about the class content, and then Thursday and Friday, this is where the action happened experimentally. We would have small group discussions. Why this is important is that let's talk a little bit about the IRB here. So we wanted to, my day job at Stanford, meaning the way that I collect data as a scientist, is someone would come in the lab, we'd stick goggles on their face, they'd leave, another person come in the lab and we'd stick goggles on their face. Obviously, during COVID, there was no way to continue doing that work. So we wanted to have these classes not only be pedagogically valuable, but to also be an experiment. And so we got permission, and it took almost all of the 15 months to do this with the IRB, and then with the Stanford group around student protection, and then with Stanford Legal. Students were able to opt into the study. They chose yay or nay about opting into the study. If they opted into the study, their data were saved. If they didn't, their data were not. Pedagogically, everyone got the same experience, regardless of whether or not they opted into the study. And there was a third-party arbiter to ensure that I never know who opted in, who opted out. We recorded everything. Everything meaning all the moves they made with their body at 90 hertz, the pitch on roll, the X, Y, and Z of head and hands, whether the mouth was open or closed. We recorded all the utterances, all of the actions. And so we created every week for 8 weeks in a row in a 10-week class, small group discussions where they met for 30 minutes. And remember, in the cadence of the week now, they've done all the readings. We've talked about it to get deep on it. Wednesday, they went on a journey that made these readings not abstract, but really come alive. And then on Thursday and Friday, they would talk about it. And what makes VR special, so right now, I'm far away in the Zoom window. Right now, I'm close. Normally, when you're on a call and you see a head get bigger, in the real world, that would signal attention, attraction. And Zoom, it probably just means that somebody got a text and they're trying to read it on the screen. It's not diagnostic. And a Zoom call, if you see someone do this, which is turn their head all the way to the left, and there's a window next to them, your brain perceives they're looking at that other person, right? It's just natural to assume that. Of course, they're not even looking at the computer anymore. The mailman just walked by and they're looking at that. In VR, all the spatiality is preserved. So the woman in the red sweater, when she leans towards the person in the pink, the others can see that she's leaned towards him. And if one person points to another, all the spatial aspects of communication are preserved. So the first time we came together as a group, and the first one was a big group in June 2021, we were in a small room. We had 60 avatars in the room. No one had ever been together with people since then because COVID was still, shelter in place was still there. And it was this incredible moment because for those who have ever been in VR, it really feels like you're there. Eye gaze is really meaningful. Personal space is meaningful. So we'd have these small group discussions and we'd collect all the data. So some people may recognize this graph from one of my favorite books in cognitive psychology, Alan Newell's Unified Theories of Cognition. And in our class, because students met for 8 weeks, 30 minutes a week in these small groups, we've now got 500 people that have gone through this, and we're recording data at the millisecond level. We can look at biological processes. When you look at processes that are 3 milliseconds later, we can look, 15 milliseconds later, we can look at cultural processes, the social band that takes months to form. We can look at all of these different time units, and it's an incredible, I will say, quite confidently that this is the largest data set anyone's ever had about VR behavior. And arguably, and I'm happy to be proven wrong here, but if you're looking at nonverbal behavior, in particular, this is the best data set to ever help people understand, well, how do groups form? Groups form. These people came together. They didn't know each other. and then we can follow them non-verbally over 10 weeks, and we can look at them at the millisecond level, at the hour level, at the month level, and it's super exciting. One of our main metrics that we're studying is nonverbal synchrony. For those who don't understand, that don't know the construct of synchrony, it's the correlation of people's movements. When a group is synchronous, they're moving together. And what you're seeing here is simply taking two people, taking some movement metric, it could be the velocity of the head, and then you, at time zero, that's the correlation. And then when you slide them over time, that becomes a control condition for total amount of movement, meaning it's not just that people are moving a lot, it's when they're moving, and you can see the bump at time zero, that's synchrony. And so computationally, I've been a scholar for 25 years, for 30 years, and the first time I've ever had to use a supercomputer for our work, because we have so much nonverbal data that computing synchrony becomes really fascinating. And also, just to talk about the importance of synchrony, when you look at the last 7 decades of studying synchrony, it correlates with outcomes in conversations, with creativity, with bonds between people who are close relationships. It's a really good behavioral metric for conversation. But here's just kind of a screenshot of we have a group of 10 people, and it turns out groups are complicated. They've got shapes, and they've got subgroups, and they've got, it's not, most of the studies that have been done with synchrony have been with dyads. And with dyads, synchrony is fairly easy. It's just a correlation. But now when you're looking at large groups, which again, this is a really unique data set. We've got a ton of data on groups. This is just looking at, so look at this cluster of 3 people. The 3 people, if you look at that 3-person cluster and you compute synchrony over a month, or whatever time unit you want, you can see that if you have A, B, A, C, and B, A, groups look really different. And so when you're thinking of the synchrony of groups, what's the right metric? Should it be, group number 8 at the top, that everybody's synchronous, or do you want someone where there's one pair that's really synchronous and the others aren't, and we're really delving into this data and building fun computational models of just how groups move together, and then what that means. Because we have output data, I should mention that after every discussion section they filled out a questionnaire with self-report questionnaire items, with free-form text that we can do natural language processing on, with rating how much they like the other members of the group. We have an incredible data set to understand a lot of the problems with nonverbal data research. If it's observational, you often don't have those labels on the output, and we do. We're also measuring their language. And so here's work by Cyan DeVoe, where we went through a very intense process of transcribing 500,000 minutes of conversation. AI gets you only so far, and you've got to have human coders that do the work. And we're building a library of what are the things people say in VR and when, and how that correlates with outcomes. So they talk about avatars or sensory processes, or even learning, because this was a class. And then you can correlate those with your questionnaire measures, and we're doing lots of fun work on that front. The final thing I'll talk about, because I'm hoping we'd have a really rich Q&A, is context. So for one of the classes, we had about 200 students, and we ended up having 192 separate discussion sections. And Ugi Han led a study where she wanted to understand the effect of context. And the 2 theoretical variables she cared about was indoor, outdoors, and then very large spaces on the XZ plane. You can see infinitely, or smaller spaces. And when you read the literature on context and how it affects social interaction, it's intensely limited. There's brilliant people doing the work, but it's really hard in the real world to have 2 different rooms that differ on one parameter, not many parameters. It's also just super expensive to do this work. So we did a stimulus sampling technique where every time we had a group of 5 programmers who was like a fire hose for them, they built a new world, 24 new worlds each week that varied very specifically on the size parameters on the indoor outdoor. And what we could do then is to try to understand what's the effect of context. And the paper is going to come out in a couple of weeks, so I don't want to get in too much detail because it's on embargo. But I will say, very big spaces psychologically are awesome. They're awesome in terms of synchrony. They're awesome in terms of self-report, in terms of collaboration quality. And one thing that no one's ever been able to study before is huge indoor spaces. So you think about awe, AWE, awe that you get from outdoor spaces. What about being alone in a stadium with just a few people? In the real world, you can't study this and you can't do this because it's expensive. But in VR, when people are having these metaverse platforms, space is free. And the finding I will talk about is that indoor huge spaces are surprisingly awesome psychologically in terms of outcomes. And we're currently running a follow-up study to get to the mechanism. Happy to talk more about that. So in conclusion, I would like to thank you for your attention. I hope you've got great questions. And here's my book. I'm not trying to sell it. Send me an email. Our traditional work is there, but I couldn't give a talk to this audience and not talk to you about our new work because I'm just super excited about it. Thank you very much. And finally, switch back to
so we definitely have time for questions. So questions for Jeremy. Yeah.
Hey Jeremy, good to see you. I don't think you can see me. It's okay. You just have to.
I can hear you.
Okay, there we go. Anyway, obviously love the talk. I'm wondering if you're looking at maybe bringing in some of the work you've done in the past with mimicry into VR to look at. Yeah. Okay. So I don't know if everyone's familiar with that, but I just love that stuff. So I don't know if you can talk a little bit about that.
So thank you for that. So we have a whole paradigm called transformed social interaction, which is in VR. You can have people's actual nonverbal behavior, but the way networking works is I send you a packet that has my movement data. I have to send that to you so that you can render me on your computer doing the movement that I'm actually doing. It's very trivial psychologically to not send my actual tracking data, but to grab yours and then to transform that. And one ways we do that is we can have me automatically mimic you for social influence. We do things with giving extra eye gaze so that the teacher is looking at everyone simultaneously and each person thinks they're only getting the gaze. What I'll talk about in specific is we have a brilliant programmer, her name is Portia. What we're doing with this course, we've got all these discussion sections, and I want to make this class bigger than Stanford. I want people to be able, we've already got a lot of the syllabus online for those who want to try to run it. I'll give you all my materials. One thing that you need, so in this fourth iteration, we decided to make discussion sections not led by TAs, okay? Every other class we had a TA and headset running the discussion section. We decided to get rid of that for two reasons. One, is it's really hard on the TA to have to wear a headset for 8 hours to run all these discussion sections. Two, we're doing natural language processing and we want natural conversations. And when there's a TA there, you don't get the turn taking and the interruptions in the same way. So what Portia is doing, back to your question on mimicry and TSI, I'm calling this the invisible guest. So we've got a discussion section, and this is a detail you need to know. When I track all of the tracking data, the movement data at 90 hertz, that data is enough so that you can feed it back into the Engage platform as if it were real-time movement and it feels as if you're there. So when I give a tour inside Engage, I have people move around, I hit a button to record it, and then all of a sudden the past emerges and it's like you just time traveled and you're walking around it. Like, so in other words, the recordings are high fidelity enough so that you can feed them back and it's as if they were happening in real time. So what Portia is doing on a TSI standpoint, imagine there's 4 people in a conversation, but I want to have, as a MOOC, as a massively online open course, I want new people to be able to come in and feel like they're a part of that conversation. On the NLP side, this is hard, but the paper that we're writing right now is based on Portia's brilliant algorithm work, which is if you have a 5th person, you've got to adjust the positionings of people so that you can be part of the group. You have to adjust the orientation, and then you got to do things like mimicry. And it's hard to think about mimicry in real time just based on how the technology of feeding in these files work, but you can do what I'm going to call blunt mimicry, which is that if someone's a big mover, you guys can tell I'm a big mover, maybe you've got 3 or 4 versions and you kind of match based on personality metrics. So we're thinking about it. This TSI paradigm where we do mimicry and all that stuff, it's been dormant for a while. And now that all these platforms are out, it's just super fun to think, well, what should we do and what should we definitely not do, for the world citizenry based on all these TSI, mimicry, and other paradigms. So thank you for that.
Thank you, Jeremy. It was a terrific talk. One of the things I wish that we had done or had been able to do with social media is before it got widely adopted in society, get people together to research the pros and cons and all the, potential harms and all that. And since you've been working in this space for so long and since VR is not widespread yet in society, I was curious what your thoughts are about what mixed reality will look like, or the metaverse, or if that's kind of a ridiculous kind of vision, and then also some of the ethical considerations that we should all be studying and thinking about.
Yeah, thank you for that. So chapter 2 of my book, which again, I'm happy to send you, is all about the downsides of VR. When I think about the downsides of VR, there's 5 of them. The one I care about most is distraction. Think about wearing the headset, you can't see the world around you. So you step on a cactus, you kick the cat. Those are jokes. where I care about a lot is driving. We know that car accidents were caused by Pokemon Go, people driving while trying to find Pokemon with augmented reality. So I do a lot of public lobbying against allowing VR to ever work from a hardware standpoint in a moving car. Stanford allows professors to do a lot of corporate work, which I'm proud of, and I spent 5 years advising Young Sohn, the president of Samsung Electronics, and I got buy-in from them to make, from a hardware standpoint, VR not work in a car. They ended up pulling away from VR. But so distractions, number one. Addiction, we have no data on, but it's certainly something to think about. When the world's perfect in VR, do you ever leave? Overuse and simulator sickness, I'm happy to go into that if it's useful. Modeling bad behaviors, intense violence is a little different in VR than it is on a 2D video game. And so far that's a good thing because people haven't been engaging in as much of it as you would think. However, I've been proudly working with US soldiers for 2 decades on using VR to make them better at their job. And when an over-the-counter boot camp costs $19 in VR, when somebody wants to do harm, they're going to be able to learn bad skills. So those are some of the downsides. In terms of what I'm doing about it, I've spent time with Mark Zuckerberg, helping him think through these issues when he was considering buying Oculus. Most of my recommendations have largely been ignored, but not all of them. And so there's some traction there. I'm on the Metaverse Steering Committee for the World Economic Forum. I'm very active in the world of organizations that think about the downsides. And in a different, actually, let's talk about in terms of this class. I am a VR miser. We've got a 30-minute rule in my lab, which is only do it for 30 minutes. Take the helmet off. I design my curriculum around that. So only about a third of our activities are in headset, and we never lecture at you in VR because Zoom works just fine for that. So I'm happy to go on. I think a lot about VR. I've written the report for Common Sense Media called VR 101, what parents need to know about their kids. I do a lot of public advocacy work, and I'm not saying I'm listened to, but I certainly can get in the room with the people who are making decisions. For example, I work with Google and Facebook and Samsung on their age limits, and I was actually ignored in the opposite way on that one. So Jackie Bailey, who's a professor at University of Texas, she's run hundreds of studies with 3-year-olds and 4-year-olds and 5-year-olds. It was funded by Sesame Workshop. And, our advice to the companies was, if a parent is present and the kid is meeting Grover and you're spending 5 minutes, VR is not going to hurt a kid. It's really not. Which now I like that they err on the side of being conservative, but the reason why their age limits are 13 is not about any health of brain. It's about the fact that you have to have a social media account, and that's the rule there. And it was easier to make that consistent. So I'll pause there, but as you can tell, I could talk a lot about this. It's important, and yeah, we're early, and we've got to be loud.
Great, thanks. Anna?
How could the students develop the avatars? Did they have some leeway? And did the avatars differ much from the real selves? And another question is space. What was the rule on space? Could someone get close? How did that work?
So the first thing on what avatar they choose for one of the 4 classes, the way your avatar looks, how much it looks like yourself, if you get to choose it, these are theoretical variables studied for 30 years now. And we want to design a study around that. So in our first study, and again, I'm being the paper's going to come out in a couple of weeks, so please just don't tweet about this. In the first study, which was 100 students over 10 weeks, half the time of the eight discussion sections, half the time they wore a self-avatar. An avatar in the Engage platform, you can take a photograph, it maps to the 3D model, you can tailor and tinker. They had to look like themselves. The other half was based on a 2006 study that I'd done about in groups, where we looked at back then we called the team avatar, now we call the uniform avatar. We created an avatar that was stripped of cues of gender and race and ethnicity, and everybody wore an avatar that was exactly the same. And the rough findings there was that when you had the anonymous avatar, enjoyment went up, but when you had the self avatar, synchrony went up, meaning behavioral synchrony went up, and then all the downstream things from that also increased. So we like being anonymous, but we're better and more productive and better groupie when you're in the self. But there is a large literature on that. In terms of personal space, we just submitted one of my favorite dependent variables is interpersonal distance, because VR part of tracking, you know, the XZ space of people, and it's trivial to get that data. So we've got incredible mathematical models of, if you think about personal space studies, you know, in the real world, our data set is 1,000x in terms of the things you can look. I mean, we're going to be publishing off this data set for 30 or 40 papers for a number of years. We just submitted a paper. You may be familiar with something called the equilibrium theory. What that states is that it's from the 1950s. We use nonverbal cues to maintain the proper level of intimacy, and gaze and distance trade off. So in an elevator, you're forced to be very close to someone so you don't stare at them in the eye. And this is the norm that's evolved. And so the great thing about our data set, and again, I hope that doesn't sound braggy, the students did all the work here, they were incredible, is that we have data over time. And you can show that the equilibrium effect, which is that people move back from others when they're being stared at and can get closer when they're not being looked at. That is a finding, and it's robust and it replicates, but it also develops temporally, right? And so when you think about how, one of the problems of VR is that everyone says it's a novelty. Once it wears off, no one's going to like it. Or people say it's a really hard medium. It's going to take a long time to figure out how to use it. And you know, we're doing analysis to try to parse those apart. And I'll pause for a follow.
That's great. Back there, got a question?
Yeah, I have one big question. I don't know whether.
Okay.
I can't hear you. Can you please come closer?
Can you? Yeah. Just do it.
Sorry.
Thank you. No, that's fine.
I'm very excited about your research because you're doing the repeat study, the same group. So my first question is, if you can give us three most obvious difference across two groups, like for instance, are they more self-aware? Are they more, more or less aggressive? Are they more or less expressive? Personality online, offline shows differences. So any interesting and obvious differences you noticed when you do in-person versus VR? That's my first question.
Yeah, so on the in-person versus VR difference, I'm going to quote the great Jaron Lanier here, the founder of VR, who says that the best moment in virtual reality is when you take the headset off and you realize how awesome the real world is and all the colors and all the great things about it. We often don't do the face-to-face control because it's just so different than the real world. So I just don't have great data on the differences. And I will say the first IRB approval for this big class, which was this monstrous, we got approval to compare Zoom to face-to-face. And in the last minute, I was heartbroken over losing, in the largest data set in history in VR, of losing 50% of it just to talk about Zoom. So we decided last second to get rid of that control condition and just use time as a measure there. So I don't have a great answer for you face-to-face. On the people in groups, I will say our colleague on statistics here, because this, to be transparent, the stats we're doing here are way above my head. I mean, the looking at time really makes the world complicated. So we have the great Neelam Ram, who's advising on this. And one surprising finding is in the way that he's doing these models is, in social psychology, we've always been told you have to treat groups as units, right? And you know, if you run a group of 5, that's one subject in terms of your random factor. Of course, the field has changed a little bit, and now you just take into account the effective group, and you see what variance that soaks up. And the particular group you're in has been soaking up a surprisingly small amount of variance in these VR studies, a little bit, but it's the kind of thing you realize. All the group studies I've done growing up, the fact that I treated a 3-person group as one subject, that's kind of a bummer. We do have personality data, all sorts of individual differences. I mean, we've got a lot of data that we can look deeper in. We're just, as I said, there's about 40 papers in this queue, and we've got 3 or 4 submitted, and a couple of them out that I'm happy to share with anybody, the ones that are out.
Okay, well, we can maybe take one more just because we've let Jeremy go. So, you have
The second quick question is the fatigue, because the fatigue and motion sickness, because that speaks to the inclusion in the future design and who may not be able to. So you're building the VR dictionary, like, is there any percentage of people have that issue that we should be aware?
So simulator sickness is a real thing. I myself have a benign paradoxical positional vertigo, so I'm the best person to run these studies because I get dizzy really quick. I can talk about when and why it happens. In our data set of 500 people, In general, my historical base rate has been about 1 in 30 people can't do VR. If you can't be a passenger in a car, for example, VR is not going to be very fun for you. So I think in our sample of about 500, I had to come up with alternative assignments for maybe about 10 to 12 of them, meaning we just had to come up with something different for them. I will say, I mentioned I have a 30-minute rule. That used to be a 20-minute rule. And if you read my 2018 book, it was a 20-minute rule back then. And the reason why it's a 30-minute rule now is because the 4 factors about the headsets: better form, not as heavy, much lower latency, meaning there's less lag between your physical movements and the world updating, higher frame rate, the world updates faster, and then something called image persistence, which I can talk about, but it's a little bit complicated.
Great, thanks a lot. So thanks so much, Jeremy, for coming. I really wish we had time to spend the day with you. So hopefully next time it'll be in person. If not, through our avatars. Okay. So
I tell you what, I now give a tour. I used to have a physical lab that people would come and I would give them tours. I now meet you in headset and I take you and engage and I show you all the stuff I would show. It's super fun. So
great.
Next time, but thank you. I really appreciate the great questions, the attention, and thank you for having me.